So our next chapter, we are starting sequences and series. Today's is going to be kind of a overview of everything that we're going to see. So it's going to be a little bit longer. But a sequence is an ordered list of numbers, like 2, 4, 6, 8. A finite sequence is a function that has a limited number of terms and whose domain is the finite set 1, 2, 3, all the way to whatever number you want in. The value in the range are called the terms of the sequence. So in this sequence that we have here, which is 2, 4, 6, 8, 10, your first term is 2, your second term is 4, your third term is 6, your fourth term is 8, and your fifth term is 10. And it goes on and on forever to the range. Finite means it has an ending number. Infinite sequence goes on forever without end or boundary. So, on our first set of problems, we're going to find the first 6 terms of the sequence. And this is written a little bit different than you're used to. A sub n is our term that we're looking for, equals n squared minus 5. So we're looking for the first 6 terms. So I'm going to write term number 1, term number 2, term number 3, 4, 5, and 6. Alrighty, so to find the first term, I'm looking at a sub 1 equals 1 squared minus 5. 1 squared is 1, 1 minus 5, so I have negative 4 for my first term. To get my second term, I'm going to look at a sub 2 equals 2 squared minus 5. 2 squared is 4, minus 5 is negative 1. My third term, a sub 3, is going to be 3 squared minus 5. 3 squared is 9. 9 minus 5 is 4. For my fourth term, I'm going to have 4 squared minus 5. 4 squared is 16. 16 minus 5 is 11. My fifth term is 5 squared minus 5. 5 squared is 25, minus 5 is 20. And my sixth term is going to be 6 squared minus 5. 6 squared is 36. 36 minus 5 is 31. So here is my sequence. It's going to be negative 4, negative 1, 4, 11, 20, and 31. Since it has an ending number, this is a finite sequence. All right, let's look at this next one. We're looking for the first 6 terms again. So I'm going to put a 1, 2, 3, 4, 5, and 6. I'm going to be working down here. Okay, so I have a little bit more room. So my domain is 1, 2, 3, 4, 5, 6. I'm finding the range. The range is the actual sequence. So f of 1 is 2 times 1 over 1 plus 2. So that gives me 2/3 as my first term. F of 2 gives me 2 times 2 over 2 plus 2. That's going to be 4 over 4, which is 1. F of 3 is going to be 2 times 3 over 3 plus 2. That's going to give me 6/5. F of 4 is 2 times 4 over 4 plus 2. That gives me 8 over 6. Always reduce your fractions, which is going to be 4/3. Next, I'm going to find f of 5. 2 times 5 over 5 plus 2. That gives me 10 over 7. Nothing to reduce there. And f of 6 is 2 times 6 over 6 plus 2. That gives me 12 over 8. Reduce. And my last one is 3/2. So your domain is 1, 2, 3, 4, 5, 6. Your range would be the sequence 2/3, 1, 6/5, 4/3, 10/7, 3/2. That's how we find the first 6 terms. You plug in the 1, you plug in the 2, you plug in the 3, and so on. Okay, we're going to be looking at 2 different sequences. The first one is arithmetic. That means that we add the same number to get to the next number. So if I add 2 and add 2 and add 2 and add 2 all the way down, that would be a linear sequence. Remember, linear is in the form of mx plus b. So if you get something that looks like 3x minus 1, that is going to be linear, because when we graph that, it's going to give you a linear line. Okay? The next one is geometric. Geometric multiplies the same number, so I can multiply by 2, multiply by 2, and multiply by 2, and multiply by 2. What actually would a sequence like that look like? So if I start with 1, multiply by 2, I get 2, multiply by 2, I get 4, multiply by 2, I get 8, multiply by 2, I get 16. Okay, this is an exponential graph. So you're going to have something to an exponent. On this one, we're going to have 2 to the n power. So 2 to the first is 2, 2 to the second is 4, and so on. So when we graph this, and you'll be able to tell the graphs, because this one will be more of an exponential graph. Exponential, and this one over here is linear. Exponential and linear. All right, so for the next one, we have describe the pattern, write the next term, and write a rule for the nth term of the pattern. So I always start out with, let's see how to get from here to here. I always start with adding or subtracting. So if I take 4.2 minus 5.8, I get negative 1.6. Let's check it again. 2.6 minus 4.2, and I get negative 1.6. So I can add or subtract. If I do that, that's going to be an arithmetic sequence. Okay. Now it says write a rule. Write a rule. So if this is my first term, this is my second term, this is my third term, how am I going to figure out how to get that? Well, you'll be given a formula tomorrow. So how can I do this? Well, whatever you're subtracting or adding is actually your slope. So we're going to look at a sub n equals negative 1.6. And then this right here is always your plus 5.8. So I need to know what my variable is going to be there. So if I just put an n here, if I put in 1, am I going to get 5.8? No, I have to put n minus 1. So now that's going to give me a sub n equals negative 1.6 n plus 7.4. There's our rule. If I want to find the 20th term, I can. So this is arithmetic. Any questions? All right, so the next one is find the next term. Well, my last term was negative 0.6. So if I take negative 0.6, and what am I doing each time? I'm subtracting 1.6. I'm going to get my next term to be negative 2.2. So it's arithmetic. Here's the formula. And my next term is negative 2.2. All right, let's look at this next one. Now, right off the bat, I know I'm not going to be adding or subtracting. The reason is I see my numbers going from positive to negative to positive to negative, and the only way I can do that is by multiplying by something. So how can I get from here to here? Well, I can multiply by negative 2. Does that work again? Multiplying by negative 2. All right, so on this one, since we're multiplying by negative 2, that would be geometric. All right, so now we need to come up with some type of a rule. Okay, so a sub n equals, I'm multiplying by negative 2, so that's going to be the base of my exponential. Now, if I take negative 2 to the first, I should be getting a 1. So I have to subtract 1. Because what is 1 minus 1? 0. Anything to the 0 power is 1. If I put in a 2, 2 minus 1 is 1. So negative 2 to the first is negative 2, which is my second term. So there is my rule. Next, we need the next term. So I take 16 times negative 2. Next term is going to end up to be negative 32. So it's geometric. There's my rule. And my next term is negative 2. All right, let's look at this last one here. Well, I know I'm not adding or subtracting anything because that 2 stays on top. And then what's happening down here? I'm multiplying by 2. Am I multiplying by 2 again? No, I'm not. I'm adding 3. Am I adding 3 again? Yes. Am I adding 3 again? Yes. So I'm adding by 3s on the bottom, and my top stays the same. So this is a neither. All right, but we can still come up with our rule. What do I know about the top? Well, that's easy. It always stays a 2. Now I need to work on the bottom. So on the bottom, I'm going to take, since I'm adding, remember that is your slope. So 3 times something. So 3 times n. So if I put n for my first term, it'd be 2/3. If I put a 2 in for my second term, it's going to be 2/6. If I put a 3 in for my third term, it's going to be 2/3. So there's my rule. Now I need to get my next term. Ooh, erase. And back to next term. I did it again. T-E-R-M. Woo. Next term. I'm going to have 2 over, and this was the third term. This is the fourth term. So I'm looking for the fifth term. So I'm going to take 3 times 5, and that's going to give me 2/15. So 2/15 would be my next term. All right. Here's something a little bit new. We're looking at series. Series is definitely new. Series is when we are adding up our whole sequence together. The resulting expression is a series. A series can be finite, which means it has an end, or it can be infinite, which means it goes without bounds, and you can write it in summation notation, and this is the sigma notation. This little thing right here, sigma notation. At the bottom, it tells what term you're going to start with. Over here, it might be I plus 2, okay? And then I'm going to put in a number up here, and if I put in a number, that means it's going to have an ending term. It's finite. So to get this sequence, I would put these numbers in, and I'm going to go from 1 all the way to 3. So 1 plus 2 is my first term, and that is 3. My second term means I'll put in a 2. 2 plus 2 is 4. And then I'm going to stop at my third term and put a 3 plus 2 is 5. So the sequence for this is 3, 4, 5. But what that sigma notation means is I'm going to add these up. And so my answer comes out to be 12. Okay, so this right here would be my answer. So let's look at these. On this one, if I put in a 1, I get 2. If I put in a 2, I get 4. If I put in a 3, I get 6. If I put in a 4, I get 8. And so if I add those up, I get the answer 20. So 20 is going to be my answer for this finite series. This infinite series, can we add these all up infinitely? No. So towards the end of next week, we'll be looking at infinite series. So let's look and see what we're doing here. We are going to write the summation. Writing the summation. So let's start out with our little sigma notation. And you can do an I equals, you can do an N equals, you can make it K equals, and we're going to start with 1. Okay, I'm just using a K because I don't want you to get used to the same letter, seeing it. So on this one, let's see if it's arithmetic or geometric. I would add 3, add 3, so I know it's arithmetic. That means it's going to be in the form of mx plus b. And what do I know my slope is? It's 3. So this is my first term, this is my second term, this is my third term. So 2 times 1 plus what is going to give me 7? 4. Okay, let's see if that works again. 3 times 2 plus what is going to give me 10? And your answer is 4. So right here, I replace my 1 and my 2 with the k. So 3k plus 4 is my formula. Okay, so that goes right there. And then how many terms do we have? 1, 2, 3, 4, and we have 5. So this was written in summation notation. All right, let's try this next one. First, we write the sigma notation. Let's use n this time. We're going to go from n equals 1 to I don't know. Well, actually, I do, because what do those dots mean? Those dots mean forever. And what symbol do we give to forever? We give the infinity sign. So now we have n equals 1. We have to come up with our formula. Okay, so I like the top. I know it's going to be 1 over. And now what's happening to the bottom? Well, I'm multiplying by 3, multiplying by 3, multiplying by 3. So I know that's going to be 3 to the n power. Okay, so now let's test it. If I put in my first term, 3 to the first gives me 3. If I put in my second term, 3 to the second one is 9. So this is going to be 3 to the n power. And there's our sigma notation. Okay, we have a couple more slides. On this one, we're going to find the sum. So I'm going to start off with, I know that there's going to be 6 terms. So 1, 2, 3, 4, 5, 6. And I'm going to start by putting 1 in here. So 4 times 1 is 4. Then I'm going to go and I'm going to put 2 in. 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. 4 times 6 is 24. And then guess what we do? We add those up on our handy dandy calculator. And when we do, we should get the total of 84. So you find every single term, and when you're done, you add them up, and you should get 84. All right, we're going to do the same thing for this next one. This time, how many terms do I have? I have a total of 8. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, what I noticed, actually, I made a mistake. What mistake did I make? Does it start with 1? No, we are starting with 2. Oh. So I have 2 over 2, which gives me 1, plus 2 over 3 is 2/3, plus 2 over 4 is 1/2, plus 2 over 5 is 2/5, plus 2 over 6 is 1/3, plus 2 over 7 is 2/7, plus 2 over 8 is 1/4. So now we're going to add all these up. You can either find a common denominator or you can just add them up on your calculator. And when you do so, you should get 481 over 140. So remember, even though you might not have a graphing calculator, you can still use a scientific calculator. And again, always check to see where we start, because even Miss Bobby made a mistake and tried to start with number 1. But no, when we re-examine it, we start with 2. Alrighty, we are done. So what is a sequence? It is a list of numbers. What's the difference between arithmetic and geometric? Arithmetic, you always add or subtract. So add. And geometric, you multiply. What is a series? It is the sum of the list of numbers. What is summation notation? It's your sigma. It has a starting value. It doesn't always have to be 1. It has a formula over here. Could be 2n minus 1. And then it has an ending value, ending term. And it could be a number or it could be infinity. So if you have any questions, make sure that you talk to your teachers. So your assignment is Big Ideas 6.1. We are in our last chapter of the year, so let's take it seriously. Next year, your pre-calc teachers will know that you learned this, at least touched on it, so they're not going to have to start from the very, very beginning. So please keep